we want to multiply and then simplify the following two radical expressions. The square root of 27 x times y multiply with the square root of 9 times x times y squared. In order to multiply these two expressions, I need to remember that I have the following property for square roots. That the square root of something multiplied with the square root of something else is the same thing as the square roots of the product of the insides. I'm going to be using this in the following way. This, in my first step, I will go from here to there. I will multiply the radicands inside. The radicands is whatever is underneath the radical sign. And then afterwards, in my second step, I'm going to do something with this part right here. And I'm going to use the same property backwards to split this up. And I am going to split up perfect squares. This is the idea. Now let's do it. So, in my first step, I have that I am producing basically a big square root, and this is going to be the square root of 27xy times 9xy squared. So I will multiply these two expressions underneath the radical sign out now using my rules for exponents. 9 times 27. My goodness, let's have a look. 10 times 27 would be 270. But I had only 9 times 27, so I have to subtract 27 again. And that will then give me 200 and, let's have a look, 243. Please correct me if that's not right. 243 plus 27 is 270. So I have 243. X times x, both have an exponent of 1. I add the exponents and I get x squared. Y to the first times y to the second is y to the 1 plus 2 is 3. All right. Now that I have the first part done, I multiplied both expressions. Now I need to simplify. And what I'm going to be doing is I'm going to be taking this and I am going to split this into two parts. In my first part, I'm going to write perfect squares. And in my second part, the second factor, I just leave the rest. Let's have a look. The first thing that we are going to look at is the number 243. 243. Let's have a look. How can we do this easier? Look at this one. 27 times 9 is what we had was 243. Now 27 is the same thing as 3 cubed. 9 is the same thing as 3 squared. Now, if I multiply these together using my rules of exponents, I will get 3 raised to the 5th. I add the exponents. What this tells me now is that there is an even exponent inside the 5, and this is 3 raised to the 4th. And I still have 3 left over. Now 3 raised to the 4th, that is 81. I have 81, and I basically take this 3 raised to the 4th, and I put this first. But I still have this factor of multiplied by 3 right there, because both of these together will have to still get 243. All right. So 81 times 3. 81 will be the perfect square. Now I look at the variable x. X squared is already a perfect square. That comes to the first part. These parts right here, these ones will be perfect. and this part right here is going to be the rest or the leftover. Excuse me, if you want to think about it this way. Now I look at y to the third. Y to the third is the same thing. There is an even exponent hidden inside y to the third, and that is y to the second. And I will always take the biggest one that I can possibly separate. So I have here for my perfect ones y squared, and I'm still having left one factor of y. Now look at this. These two, 81x squared times y squared multiplied with 3y, is still the same thing as 243x squared y squared. We didn't really change anything. We just changed the look. We put the perfect squares first, and then we just, if we have something left over, we collect the rest as the last factor, as the second factor. Because what I'm going to be doing now is what I've told you at the beginning. We are now going to use this property right here backwards, that I can take this and I can now split this back up again into the square root of 81 times x squared times y squared multiplied by the square roots of 3y. And now, because the first factor now, the square root of 81x squared y squared, is a perfect square, let's write it like this so that you see. This is the square root of something squared. And what comes inside right here? Well, 81 is the same thing as 9 squared. 9 times x times y multiplied by this rest 3y. And now, strictly speaking, the square root of 9 times x times y squared would be the absolute value, but in this section we are ignoring absolute values. We are just assuming that all variables are only positive. So now is when we're doing the second part, and I am opening up this last bit. The square roots of 9xy squared is just going to be 9xy, and I still have a little bit square root left. This is the square root of 3y, and this will then be my answer. In other words, I have split up as many perfect squares as I possibly could.